Assalamu alaikum. Assalamu alaikum, students. I am Sir Ahmed Shah. Today we are discussing the electrochemistry topic, aqueous copper sulfate cases. In the previous lecture, we have discussed about the definitions of electrolysis, types of electrolytes, process of electrolysis, and the preferential discharge in the part 1. In the part 2, we have discussed only the molten cases of different compounds, and the case number 3, only the concentrated aqueous and dilute aqueous solutions of various compounds and acids as well. Today, we have to discuss about the copper sulfate solution by using active electrodes, means copper electrodes, and inert electrode like carbon graphite or platinum as well. Now, we have to start our lectures today. What happened when aqueous copper sulfate solution is electrolyzed? We know that aqueous copper to sulfate solution contains H positive ion, copper 2 ion, sulfate, and hydroxide ions. If carbon graphite means inert electrodes are used, these following reactions occur. At cathode, we know that reduction, gain of electron, or decrease in oxidation number occurs at cathode because cathode is negatively charged plate, so positive charge ions are moved towards the cathode under the influence of the current. We know that copper ions are less reactive than hydrogen because copper ions are present in the reactivity series below hydrogen. So the reactivity decreases down the series. So hydrogen is little bit more reactive than copper. So hydrogen cannot accept electron, but copper accepts electron easily. So copper being less reactive than hydrogen, so discharge neutralized at the cathode. The mass of cathode increased due to the deposition of pink solid copper. Copper ions from the solution, they accept electron. As a result, solid copper, the appearance of the solid copper at cathode is pink solid, red brown solid. Both the words can be used. So when electrolysis is going on, the size of cathode, mass of cathode must be increasing. The blue color of the solution becomes colorless, fades, and solution becomes acidic, which turns blue litmus red. The reason behind it, the solution becomes acidic. The reason is here. First, we have to discuss the what happened at anode. Oxidation, loss of electron, or increase in oxidation number means charge number occurs, increases. Hydroxide ions and sulfate ions move towards the anode. We know that sulfate and nitrate ion cannot be discharged at anode ever. So hydroxide are there due to the more concentration of water than sulfate ions or nitrate ions. So hydroxide ions are less reactive, so they discharge at anode. As a result, oxygen gas is given off. We are discussing the electrolysis of aqueous copper to sulfate by using the inert electrode. Inert means non-reactive like carbon graphite as well as platinum. These two type of electrodes are used during the electrolysis is known as inert electrodes. So by using the inert electrodes, electrolysis can be done. The following reaction take place at cathode and anode. So copper ions from the solution, they travel towards the cathode, gain electron. As a result, solid pink copper or red brown copper deposited on cathode. So the size or mass of the cathode gradually increasing. The blue color of the solution becomes colorless. The reason behind it is because copper ions, they have been discharged at cathode. Hydroxide ions, they discharge at anode. We have remain H positive ions in the solution as well as sulfate ions which are present in the solution. So they become sulfuric acid means H2SO4. Hydrogen ions combine with the sulfate ions, they produce H2SO4. The reason behind it, solution becomes acidic. The color of the solution, copper sulfate color solution is blue, and the solution becomes colorless or fades due to the decrease in the concentration of copper ions in the solution. So we have to recap it again. At cathode, size of the cathode increasing, mass of the cathode increasing due to the deposition of copper ions at cathode. Similarly, oxygen gas is evolved at anode because sulfate ion or nitrate ion cannot be discharged at anode ever. So hydroxide ion, they produce oxygen gas, water again. So loss of electron is there. Now we are discussing the factors affecting on electrolysis. Before discussing this topic, aqueous copper sulfate, what happened when electric current is passed through the aqueous copper sulfate solution by using inert electrode. Now we have to discuss what are the factors when different type of electrodes are used. The case is here, concentration of ions does not affect the discharge of cations. So positive ion, copper ion, if they present in the solution, as well as hydrogen ions from the water, so concentration does not affect the discharge of cation ever. Concentration affect the discharge of anions, yes. In aqueous concentrated solution, halogen discharge before OH ion, but we have sulfate ions in the solution. So sulfate and nitrate, they never be discharged at anode. Just hydroxide ion, they must travel toward the anode or they produce oxygen gas. Example, aqueous HCl, aqueous NaCl solution, aqueous dilute HCl gives oxygen and hydrogen gas in the ratio of 1:2. 1 part oxygen and 2 part of hydrogen gas. This is the aqueous HCl or aqueous sodium chloride. If concentrated HCl or concentrated sodium chloride solution, they give hydrogen gas in the ratio of 1:1. How can we retrieve this topic? Now we have to consider the one more picture. So we are sharing the picture. Just wait. When the concentrated sodium chloride solution or concentrated HCl solution or HBr solution or HI solution is electrolyzed, then the ratio of the gases which are produced at cathode and anode can be shown by this diagram. When we open the circuit, electric current is passed through the aqueous concentrated sodium chloride or aqueous concentrated HCl solution. So if it is a cathode or it is an anode, so we can say that both the tubes are filled by the gases equal in volume. So equal volume should be obtained if concentrated aqueous sodium chloride, aqueous potassium chloride, aqueous HCl, HBr, HI solution. So this type of diagram should be shown. So one part of hydrogen and one part of chlorine or one part of hydrogen, one part of bromine or one part of hydrogen along with the one part of iodine. The ratio remains same 1:1 if concentrated aqueous sodium chloride ionic compound or hydrochloric acid, hydrobromic acid, or hydroiodic acid are electrolyzed. So this diagram should be drawn for these cases. Now, this diagram should be drawn when the aqueous dilute solution of acids, aqueous dilute solution of HCl, aqueous dilute solution of sulfuric acid, nitric acid, sodium chloride, any kind of solution is there if it is aqueous dilute. But concentrated dilute sulfuric acid as well as concentrated sulfuric acid give the same result, and it has been discussed in the previous lecture in the part 2. So what happened when electric current is passed through the aqueous dilute solution of acids or aqueous solutions of ionic compound? Hydrogen gas should be discharged at cathode while oxygen gas is discharged at anode. The ratio between the gases is 2:1, 2 part of hydrogen but 1 part of oxygen, or oxygen is 1 part and 2 parts of hydrogen. The result is oxygen can be obtained by the electrolysis of anode by the ions of hydroxide ions. So hydroxide ions can be discharged in this manner. So four hydrogen ions, they travel towards the cathode gains electron, then hydrogen gas is formed. But this reaction occurs at cathode, but the reaction at anode is four OH ions, they travel toward the anode, they produce oxygen gas in the ratio of 1. 4 electron is released during the reaction along with 2 water molecules also form. So 4 oxygen, 4 hydrogen, 4 electron. This reaction should be done at anode. The gas which is produced at cathode is the form of hydrogen. The ratio of hydrogen is 2 and the ratio of oxygen is 1. This oxygen is produced at anode. So this type of diagram can be drawn, or we have to receive the result if the diagram is given. This condition should be applicable when aqueous dilute sulfuric acid, aqueous dilute nitric acid, aqueous dilute sodium chloride, hydrochloric acid, or any other solution. Now we have to back again our lecture. So we have revert again on the same slide where we are discussing the factors affecting on electrolysis. So concentration does not affect the positive ion series. Positive ions should be discharged according to their preferential scheme. Those ions which are present in the reactivity series above hydrogen, they never be discharged at cathode in presence of hydrogen or in presence of aqueous condition, either concentrated or dilute. In the previous section, we have discussed hydrogen gas should be discharged even compound is concentrated aqueous or compound is concentrated dilute. Hydrogen gas should be there. So dilute HCl gives oxygen and hydrogen gas in the ratio of 1:2. Dilute sodium chloride solution gives oxygen and hydrogen gas 1:2. Aqueous dilute solution of sodium chloride, potassium chloride, any other ionic compound is aqueous dilute condition. They must produce hydrogen gas in the form of 2 and the oxygen gas in the form of 1 mole or 1 ratio. But all concentrated solution like HCl, sodium chloride gives chlorine and hydrogen gas, the ratio is remain same 1:1. If compound contains sodium chloride concentrated, the result remains same hydrogen gas at cathode or chlorine gas at anode. So we can see that both the cases have the same product like dilute compound or concentrated compound. Hydrogen gas must be produced, but their ratio is different. Concentrated solution gives one part of hydrogen gas and dilute solution gives two parts of hydrogen gas. But one part oxygen and one part of chlorine or bromine or iodine. So types of electrode also affect the rate of electrolysis and the nature of electrolysis as well. If types of electrode is inert electrode are used according to the electrochemical series. Little bit earlier, we have discussed aqueous copper sulfate solution. So copper ions discharge at the cathode because least reactive than hydrogen. So that is why inert electrodes follow the electrochemical series. Electrolysis with reactive. For example, electrodes is affected means electrolysis of aqueous copper to sulfate by using carbon electrode, graphite electrode, or platinum electrode, copper metal deposited at cathode, and oxygen gas produced, and the color of solution changes from blue to colorless, fades due to the decrease in concentration of copper ions from the solution. When copper ion decreases their concentration, so blue color changes to colorless or fades. But solution remains acidic due to the remaining part of hydrogen and sulfate when they combine. They produce acidic solution, and this acidic solution turns blue litmus red. But We use copper electrode in the copper sulfate solution. So this is called active electrode. The copper anode dissolves and deposit at cathode. So mass of the cathode definitely increasing in both the cases. Even carbon inert electrodes are used or active electrodes are used during electrolysis of aqueous copper to sulfate. There is no effect of concentrated aqueous copper to sulfate or dilute aqueous copper to sulfate. Hydrogen ion cannot be displaced copper because copper is found below the reactivity than hydrogen. So this is least reactive. It can accept electron easily than hydrogen. So copper metal deposited at cathode in both the cases. Even copper active electrodes are used or inert electrodes are used. So anode dissolve in this case, while in the carbon electrode, oxygen gas due to the migration of hydroxide ions at anode to produce oxygen gas. But anode in this case, when copper sulfate solution contain copper metal anode and cathode, so in the case of copper anode just dissolve in the solution and the color of solution remains blue or solution is acidic in both the cases. Mass of cathode, size of cathode increasing in both the cases. Even carbon electrode or copper electrode are used. But the anode products are same. If carbon electrode are used, then oxygen gas is produced. When active copper electrode are used, the copper anode dissolve in the solution, produces ions in the solution. That is why color of the solution remains blue, but the nature of solution, both the solutions are acidic. Now, we have to apply one more thing, which is called application of electrolysis. They are the applications of electrolysis for the extraction of metals like aluminum, and it has been discussed in the previous section, extraction of aluminum and extraction of iron as well. Those metals which are formed reactivity series above from potassium, sodium, calcium, magnesium, and aluminum. They are called highly reactive matters, so they can be reduced from their minerals through electrolysis. Electro-refining process, for example, refining of impure copper, it will be discussed later on because this case also used to for refining of impure copper. So this would be considered as the copper sulfate electrolysis of copper sulfate solution by using active electrode. This is called industrial advantages or uses of electrochemistry or electrolysis. Preparation of chemicals like sodium hydroxide by the electrolysis of brine, electroplating like galvanizing, deposition of zinc metal onto another metal like gold plating, silver plating, nickel plating, and chromium plating as well. They are called the industrial applications of electrolysis. Similarly, during the electrolysis, one more thing also obtained, electrochemical cells like dry cells, lead storage batteries also be done by the electrolysis process. Here, this topic is directly not related to our syllabus. How does sodium hydroxide form? But refining of impure copper, it is the necessary and essential for our topic in our syllabus as well. This is called purification of impure copper. So it is called active electrode. It has been discussed little bit before. If you remember, what happened when copper sulfate solution contained copper metals rod. This is called active electrode by using active electrode electrolysis of aqueous copper sulfate using active electrode. Solution is copper sulfate. Cathode, anode both are copper metals. So anode is little bit larger than the cathode. The cathode should be thin, but anode should be larger or thick. What happened when electrolysis is done? So before on the circuit, we have to discuss cathode is made of pure copper. Yes, because copper ions from the solution, they must deposit it at the cathode. That is why size of cathode increasing by change in time and the mass and the size of anode just decreasing because metal rod dissolve in its solution if it is connected to the external circuit with the positive plate like anode. So, anode is made of impure copper. Aqueous copper to sulfate used as an electrolyte. During electrolysis, impure copper anode dissolves in the solution to form copper ions, and these copper ions they travel towards the cathode and deposit it onto the cathode. That is why size of the cathode increased and the color of solution remains blue. Before and after the reaction, there is no change in color of solution because anode continuously dissolved in the solution produces copper ions in the solution, and the remaining solution is acidic due to the presence of hydrogen ions from the water and sulfate ions from the copper sulfate. So resulting solution is acidic as well as blue. And the all impurities which are present in the impure substance, it can be collected below the anode. So it is called anode mud. Now the whole process can be shown by the animated here part of the lecture. When we on the circuit, when circuit is on, the passage of current is possible, size of cathode gradually increasing and size of anode gradually decreasing. These anode rod easily dissolve in its solution, produces copper ion, and the copper ion from the solution, they travel towards the cathode, deposited onto the cathode by the help of the current. See it again, see it again. Before reaction, thick copper anode dissolve in the solution and thin copper electrode should be increased in mass and size also increase. Before reaction, color of solution is blue and after reaction remains blue due to the presence of copper ions in the solution. Now, see it again. When we on the circuit, passage of current is possible, so size of anode decreasing, but size of cathode is increasing. The reason is anode is made of impure copper and copper ion deposit at the cathode, but during electrolysis, impure copper anode dissolve in the solution to form copper ion. This is called electrolysis of copper sulfate solution by using active electrode. Solution contain copper ions, cathode anode both are made by copper. So this is called electrical refining of copper as well as electrolysis of copper sulfate by using active electrode. Active means the solution contains the same type of matter. Now we are discussing again few more examples for your understanding and better learning. What happened when aqueous copper sulfate solution are using inert electrode like graphite or platina, and the second case aqueous copper sulfate solution by electrolyzed during electrolysis, active copper electrode are used. Copper sulfate dissolved in water produces copper ions, sulfate ions, and water contain H positive ion along with the OH negative ions. So, when electric current is passed through the solution, hydrogen is reactive, then copper or copper are least reactive. So, copper ions from the solution, they travel towards the cathode negative plate. As a result, solid pink copper deposited at cathode and size of cathode increasing. Sulfate ion never be discharged, so just hydroxide ion, they just travel toward the anode, produce oxygen gas. While electrolysis of aqueous copper sulfate by using active electrode with copper sulfate, using copper electrodes, cathode and anode both are copper. So copper sulfate solution also contain copper ions, sulfate ions, and we have discussed so many times, sulfate and nitrate, they never be discharged at anode. They have no affection by the electric current towards the nitrate because they are highly reactive, so they cannot be discharged. But hydroxide are least reactive, that is why they travel towards the anode. But in the case of active copper electrode, there is no OH ion traveling towards the anode, but this happened at anode. Copper solid dissolved in its solution produces aqueous copper ions in the solution, and these copper ions they just travel towards the cathode. That is why solid copper deposited on the cathode, size of copper cathode is increasing. Both the cases have the same language, solid copper pink deposited or red brown deposit at cathode and its mass and size increase means cathode size increasing. Solid copper pink solid or red brown solid deposited at cathode and its mass and size increased. Remaining solution is acidic for both the cases. Even inert electrodes, carbon or graphite electrode or platinum electrode is used. Remaining resulting solution is acidic. Color of solution fades in by using inert electrode, but color of blue solution remains unchanged due to the continuous presence of copper ions by the dissolve of anode, copper anode. But both the cases have the same language. Solution is acidic, solution is acidic. Size of copper increasing, size of copper cathode increasing. Oxygen gas is produced at anode when inert graphite platinum electrode are used in copper sulfate, but when active copper sulfate electrodes are used, then anode dissolved in the solution produces copper ions, but these ions travel towards the cathode and deposit it at cathode. So, this is the cases related to the inert and active copper sulfate. For the purpose of better learning, now we are discussing one more thing. Same result, same language is there, but copper nitrate salt is used. We know that all nitrates ions are soluble, all sulfate compound salts are soluble except few. Calcium sulfate, barium sulfate, and lead 2 sulfate. These sulfates are insoluble, but the rest of the sulfate containing salt are soluble. All nitrates are soluble. There is no single exception is here. Aqueous copper nitrate solution using inert graphite electrode. Aqueous copper nitrate solution using active copper electrode. Results are same because sulfate and nitrate, they never be discharged. They never be discharged. What happened here? Same result you can see at cathode, copper ion, they travel towards the cathode, get the electron, accept the electron, solid pink copper deposited at cathode. As a result, size of cathode increasing. Nitrate ion never be discharged, so OH ion, they travel towards the anode, they produce oxygen gas, resulting solution is acidic. Color of solution fades due to the decrease in concentration of copper ion because these copper ions, they just travel towards the cathode and deposit it as solid copper metal. That is why other case contain dissolve of anode ions. The copper anode dissolve in the solution, produces copper 2 ions in the solution, and these copper ions, they travel towards the cathode where they gain electron and red solid, pink solid, or red brown solid is deposited. But color of this solution remains unchanged because anode continuously dissolve in the solution produces copper 2 ions, and due to the presence of copper ions, color of solution remains. To dissolve, anode just dissolve in the solution gradually, size of anode decreasing, but size of cathode increasing. Now, one more example for your easiness, and after the completion of this topic, we have to finish our lecture, and then next lecture would contain the next topic, electrochemical cell and what are there. Now, one more case for your easiness for understanding the topic clearly. What happened when aqueous nickel sulfate is electrolyzed by using inert means graphite or platinum electrode. Graphite is also known as carbon electrode. The results are same, but color of solution different because copper sulfate solution is blue, nickel sulfate solution is green, chromium sulfate solution is green also. Nickel sulfate and chromium sulfate is electrolyzed. The nickel ion at the cathode, the discharge by accepting electron at cathode The solid silvery white nickel matter is deposited at cathode, and the result is same. Mass and size of cathode is increased. Remaining solution is acidic, which turns blue litmus red, and the green color of solution fades because escape of nickel molecule, nickel ions to the cathode, and nickel is deposited in solid form at cathode. And oxygen gas is discharged at anode. What happened when aqueous nickel sulfate is electrolyzed by using active nickel electrode? Solution is nickel sulfate, and cathode anode are made by nickel. So nickel sulfate produce nickel ions, sulfate ions in the solution. Sulfate and nitrate ions never be discharged during electrolysis. Even solution is molten or aqueous condition, sulfate ions never be discharged. So the solid nickel metal anode dissolved in the solution produces nickel ions. These nickel ions in the aqueous solution, they travel towards the cathode under the influence of current. Nickel ion accept electron and solid nickel deposited, and the appearance of nickel or chromium metal is silvery white. But the color of the green solution remains unchanged due to the continuous production of nickel ion by the dissolving of an nickel anode in the solution. But the acidic solution remains, and the solution remains. Even carbon graphite platinum electrode are used or active electrode are used, solution remains acidic. Color of solution fades by using inert electrode. Color of solution does not fade, remains unchanged due to the continuous production of nickel ions, which is by the dissolving of nickel anode. Now, this is the end of our topic today. Inshallah, we will see you again in the next lecture by using the new concept. Thank you very much for your time.